LEMUR 2A, the second-generation limbed excursion mechanical utility robot, is a six-limbed walking robot developed at NASA's Jet Propulsion Laboratory. LEMUR is distinct in part because each limb was designed to be used for both walking and manipulation. It is intended to be a prototype of a dexterous, operationally flexible robot for on-orbit assembly, inspection, and maintenance. This video illustrates LEMUR completing an autonomous assembly task. LEMUR, as part of a robotic team, is helping to assemble a structure. In this demonstration, it will autonomously walk through a truss, locate a task board, and tighten a bolt on that board. LEMUR begins by walking approximately 2 meters through a truss structure. In this phase, LEMUR uses a pedometry algorithm for navigation. It calculates distance traveled from known step size and number. Future work will include the ability for LEMUR to visually track its motion through the truss and autonomously replan its path. Due to various factors such as available straight-line path, kinematic error, and foot slip, LEMUR must correct its final position before beginning manipulation operations on the task board. In this next phase, LEMUR will use vision-based algorithms to accurately align itself to the task board on which the target bolt is located. Using its omnidirectional movement capability, LEMUR first walks sideways until the task board comes into view. Once the board is in view, LEMUR finds the 3 black circles mounted on the board. These are used as fiducial markers by LEMUR's vision system to identify the relative position and orientation of the task board. Based on this information, LEMUR computes how far sideways and forward it needs to walk to be in position for manipulation. First, it checks and corrects the sideways alignment. After the sideways alignment is completed, it checks and corrects the forward alignment. LEMUR repeats this process until its position is accurate to within 2 centimeters in each direction. LEMUR also uses the fiducial markers to help locate the target bolt. In addition, accuracy is increased using a process called hybrid image plane stereo, or HIPS, which accurately aligns the camera and manipulator coordinate systems. Once the tool is placed on the bolt head, LEMUR generates a slow spin of the tool. In addition, LEMUR moves the tool in the direction of the bolt as it spins, so that the tool stays on the bolt head as it is tightened. This direction is established by the vision system, and the distance moved is determined by the pitch of the fastener. During this operation, LEMUR monitors the motor current of the driver. A sharp increase in this current indicates to LEMUR that the bolt is secure. With the target bolt tightened, LEMUR moves the limb back to the walking pose so that it can proceed to other assembly tasks. LEMUR 2A, the limbed excursion mechanical utility robot, is a 6-limbed walking robot developed by NASA's Jet Propulsion Laboratory. LEMUR is distinct in part because each limb was designed to be used for both walking and manipulation. LEMUR walks using an alternating tripod gait in which 3 limbs are used for support while the other 3 are moved. In this mode, LEMUR can move in any direction with step sizes up to 10 centimeters. That ability, coupled with the stereo cameras mounted on a circular track, means that LEMUR rarely needs to turn itself while walking or working. The advantage is a much more operationally efficient system. In addition to traveling by walking, LEMUR can adjust the position and orientation of its body within a given stance. It can move its body up and down, left and right, forward and back. It can also adjust its pose in roll, pitch, and yaw. To compensate for navigation error, LEMUR uses visually based algorithms to align itself with its recharging station before it docks. LEMUR observes the 3 white circles on the floor, known as fiducials, in order to calculate its position and orientation relative to the docking station. At this point, LEMUR docks with the station by moving straight down. To illustrate the dynamic nature of visually guided docking, LEMUR is moved a small amount to inject an error into the scenario, and then commanded to repeat the docking procedure. In this sequence, LEMUR performs 1 orientation adjustment and 2 position adjustments to align itself within tolerance. Several modular tools have been developed for LEMUR. In this clip, LEMUR uses a task light, a rotary tool, and an inspection camera to fasten a bolt and confirm success. First, LEMUR arranges its limbs to maintain stability during manipulation operations. Then, it directs its task light towards the expected location of the bolt. LEMUR then identifies the bolt's actual location and orientation by observing the black fiducial circles located near the bolt head. LEMUR can then place the driver tool on the bolt head. As the bolt is tightened, LEMUR moves the driver tool downward to maintain contact with the bolt head. During this operation, LEMUR monitors the motor current of the driver. A sharp increase in this current indicates to LEMUR that the bolt is secure. LEMUR returns the limb with the driver tool back to the standing mode, and then it raises the inspection camera to verify that the bolt has been fully tightened. With the target bolt tightened and verified, LEMUR moves all limbs back to their walking poses so that it can proceed to other assembly tasks.